Hello and welcome to this lab demonstration on monitoring virtual machine performance. After completing this lab video, you will be able to monitor performance of a virtual machine. Why is this important? Well, think of a situation where someone complains that a virtual machine doesn't perform well. When performance issues are reported, you have to identify what is really going on. How severe is the issue? How often does it happen? For how long does it happen? It's a different story when we occasionally face short-time CPU contention versus having 100% CPU load for longer periods. The vSphere user interface offers an excellent tool to monitor lots of virtual machine performance-related data. In this lab, we will focus on real-time CPU performance charts. To benefit most from this lab demonstration, you should be familiar with the vSphere client user interface. You should have some basic understanding of virtualized resources, and you should know about mechanisms that can be used to control virtual machine resources. In the first task of this lab exercise, we will cause heavy CPU workload by starting a script that performs CPU-intensive sign computations on two virtual machines. These two virtual machines are pre-configured in a way that they both run on the same physical CPU, and one of them is configured with higher CPU shares than the other one. In the second task, we will use vCenter server performance charts to monitor CPU use. We will have a look at the CPU readiness and usage values while the scripts are running. And then we will stop the scripts and check if and how this affects the monitored CPU values. In the last task of the lab, we will reconfigure the two virtual machines back to default settings. We will disable the scheduling affinity that forced the two virtual machines to run on the same physical CPU, and we will set the CPU shares to normal, so that they have equal priority regarding the CPU cycles they get during contention. I'm sure I provided you enough good reasons to watch the following video on monitoring virtual machine performance. Now, let's get started. We want to perform the configuration on vCenter server SA-VCSA-01, so the first step is to connect to this server. Then we log in as administrator at vSphere.local. In the first task, we will artificially cause CPU contention. We will start a CPU-intensive application on two virtual machines, Win1002 and Win1004. These two virtual machines are configured to exclusively run on the same CPU core, and one virtual machine, Win1002, is configured with 4 times the CPU shares of the other virtual machine, Win1004. To create the high CPU workload, we go to Menu, we select VMs and Templates. Now we expand the ICM data center, and in the folder Lab VMs, we can find the two virtual machines that we want to use. This is Win1002 and Win1004. We can see that both virtual machines are running. Now let's open a web console to these two virtual machines. This is the console of the VM Win1002. Let me go back to our vSphere client. We select virtual machine Win1004. And in the summary tab again, we click Launch Web Console. Here we are. Now we want to start the CPU busy script on both virtual machines. So I just started it on Win1004. Now let's go to virtual machine Win1002 and start it here as well. This script performs sign computations, and every 10 million computations it reports the amount of time it took. As I mentioned earlier, these virtual machines are pre-configured with different CPU shares, and this virtual machine here, Win10.02, has about, or actually has exactly 4 times the CPU shares that we find on Win10.04. It's 2000 versus 500. So when we have a look here, we see about 4 times the time that it takes to compute these 10 million signs. In the next task of this lab, we want to use performance charts to monitor CPU metrics. We will look at 2 CPU-related values in real time. And we will do that on both virtual machines. We will monitor the CPU usage and the CPU readiness. And just to make sure that you are not misled by the name of the second metric, CPU readiness or CPU ready indicates that a virtual CPU is ready to run but could not be scheduled on a physical CPU. A higher value therefore is worse. And note that virtual machine Win10.02 is configured with high CPU shares, which equals 2000 shares, and virtual machine Win10.04 is configured with low CPU shares, which means it has 500 shares. We select the virtual machine that we want to monitor, and we start with virtual machine Win10.02. And now in the right pane, we click Monitor, and under Performance Advanced, we get to the Advanced Performance chart. Now up here, we can click Chart Options, and we want to select the chart metric CPU. The time span should be real time. You see that we could also configure a certain time period, for example, or the last 1 hour or 2 hours. You can configure it, but in our case, we want to see real-time data. And here under Select Counters for this chart, we want to make sure that we monitor readiness and usage of the CPU. Down here under Select Object for this chart, we can select Target Objects, and our virtual machine Win10.02 is configured with a single virtual CPU. And that's what we see below, 0. That's the first virtual CPU, it starts with number 0. If we had configured this virtual machine with 2 virtual CPUs, then we would see a 0 and a 1 below. So we could choose to see the data only for a specific virtual CPU or for the overall virtual machine. In our case, the overall virtual machine and that one CPU that we have would provide identical data, simply because we don't have multiple CPUs. So let's deactivate CPU 0 and only leave the virtual machine as such, as a total entity. Now we click OK. And now we see the counters. We want to watch the same counters for the other VM, Win10.04. So we will open another vSphere client window. Let me simply duplicate this tab. And now in this vSphere client window, I will select the other virtual machine, Win10.04. And now we do the same configuration. So again, we are under Monitor, Performance Advanced. We click Chart Options. CPU is the chart metric group that we want to have. And the counters that we want to see is CPU readiness and CPU usage. It's real-time monitoring, and we simply want to see the values for the virtual machine as a whole. Now we click OK. So in this window, we are watching virtual machine Win10.04. And in the other window, we are watching Win10.02. When we look at the latest readiness, CPU readiness values, then we see that these values are pretty high. It's above 20 on Win10.02. and on Win1004 it's about 80. So we see this 4:1 ratio, and that is coming from the CPU share configuration. Remember, I told you that virtual machine Win1004 is configured with low CPU shares, that equals 500 shares, and virtual machine Win1002 is configured with high CPU shares, which equals 2000 shares. So we have a 1:4 ratio, and we see here that CPU readiness is at 80 on Win1004. The higher the value, the worse, because it means that a virtual machine was not able to be scheduled on a physical CPU. And on Win2, we have a little bit more than 20. So roughly it's the 1:4 ratio that we can see here. Now let's stop the script on both virtual machines. So the CPU load should get way less. Let's do that. So I'm going to virtual machine Win1002, and I'm simply closing the script here, and I'm doing the same on the other virtual machine Win1004. Now let's go back to our performance charts. Remember that the charts are updated every 20 seconds. So what we see is an average of a 20-second time period. And if we disabled the script, let's say in the middle of the 20 seconds, then for half of the time we still had high CPU load. For the other half we have lower CPU load, which means the value of the first 20-second interval might not represent the current state. As you can see here now, we have a new interval, and now we have a readiness of 0.34 on Win1002. On Win1004, we have a value of 11. I assume that even here on Win1004, the value will get lower, even though we only have 1/4 of the CPU shares. But assuming that we don't hit CPU contention, the shares are irrelevant. So let's wait for another value for another 20-second period. And here we go, we have a value below 1 also here now. So we can clearly see that the CPU readiness is, under normal circumstances, it should be a very low value. Once we run into CPU contention, it will increase. And what we saw here was that based on the configured CPU shares, the CPU readiness differed in the same ratio. In the third and last task of this lab, we want to reconfigure the virtual machines so that they can run on any physical CPU. In other words, we will remove the configured scheduling affinity, and we will change the CPU shares that are currently set to high on VM Win1002 and to low on VM Win1004 back to the default value of normal, which equals 1000 shares. The current settings of these virtual machines were useful to examine high CPU load and different prioritization during CPU contention, but now we want to change them back to default values. So first we will shut the virtual machines down. So in the navigator pane, I right-click Windows 10.02, I select Power, and then I select Shutdown Guest. I confirm. Then I do the same for virtual machine Win1004. So we select Power and Shutdown Guest OS. We confirm, and both VMs should be shutting down. Actually, when we look at the consoles, we can see that they are shutting down, or this one is already shut down. Let me close these windows. And we also need just a single vSphere user interface session, so I can also close this window. Why did we shut down the virtual machines? Because you cannot change the scheduling affinity on a live virtual machine. Now we right-click our first virtual machine, we click Edit Settings, we expand CPU, and you can see that here under Scheduling Affinity we forced this virtual machine to run on CPU core 1. So we simply delete the 1 here. And in addition, what we also want to do is we want to change the CPU shares. They were set to high on Win10.02, and we want to set it back to normal now. And you see that it changes the share value to 1000. Normal equals 1000 shares. Now we click OK. Now we right click Win10.04. Again, we click on Edit Settings and we do the same configuration. We change the CPU shares from low in this case to normal. So we change them from 500 to 1000, and again we want to disable scheduling affinity. So now both virtual machines are running with default shares and they can be executed on any CPU on the ESXi host. Congratulations! You have completed the Monitoring Virtual Machine Performance lab demonstration video. In the first task of this lab, we created heavy CPU workload on 2 virtual machines. Then we used the vCenter server performance charts to monitor CPU use in real time. We observed high CPU readiness values on both virtual machines, and we could see that based on the differently configured CPU shares, 2000 shares on one virtual machine and 500 shares on the other, the CPU readiness values in the chart differed in the same ratio. You now know how to monitor virtual machine performance using vCenter server performance charts. Note that there are additional tools available. For example, within the guest operating system, you can use features such as the Linux top command, or in Windows you have the performance monitor, perfmon, and the task manager. And in vSphere and on ESXi hosts, you can look at system logs and you can use command line tools such as ESXtop and its remote version, RESXtop. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware World.